All right, number 13. Let's go ahead and continue with the problems that we are doing. So we want the velocity of this person right before he hits the pillow. And let's be clear, this guy's initial speed is plus 12. The acceleration is negative 10. And their initial height is 20. And so the final position is 0. So let's just kind of be clear. We want the velocity of the man before he hits the pillow. So we will actually say here v squared is v naught squared plus 2ax minus x naught. Will be really clear. So we have an unknown v equals 12 squared plus 2 times negative 10 times 0 minus 20. And so v squared is going to end up being 144 plus 400, which is 544 for v squared. And that means v is going to end up being 23.32 meters per second. Sorry, 23.32 meters per second. How long is in the air after he lets go? So we can actually say that v is at plus v naught. So we're going to actually, let's be really clear here. I got the size of the speed, but he's falling downwards, so his speed, his velocity is negative 23.32 because it's downwards, equals negative 10 times t plus 20. So we're going to end up getting negative 43.32 equals negative 10t. T ends up being 4.33 seconds. And then what is the greatest height reached by the man above the ground? This should be bigger than 20 meters because he has an initial upward speed. So let's just go ahead and get that. And we can actually say here v squared equals v naught squared plus 2a x minus x naught. And let's be really clear here. 0 is the final speed. 20 squared is, sorry, incorrect. So v squared is 0 squared because at the tip top, at his greatest height, is speed 0. His initial speed is 12 meters per second, and we square that plus 2 times the downward acceleration of negative 10. X is what we're trying to find, and the initial height is 20. So we're going to end up getting here negative 144 equals negative 20x plus 400. So negative 544 is negative 20x. Now let me just divide by 2 to simplify. So 272 is 10x. So x ends up being 27.2 meters. And then what is the distance between the helicopter and the man 3 seconds after he lets go of the rope? What an obnoxious question. Here we go. So x of the helicopter is going to be v naught t plus x naught. And that's going to be, x of the helicopter is going to end up being 12 times 3 plus the initial height is 20. So we're going to end up getting 36 meters is the height of the helicopter at 3 seconds. Now for the man, that's going to be 1/2 times negative 10 times 3 squared plus 12 times 3 plus 20. And we can simplify this, so that's going to be negative 45 plus 36 plus 20. So that's going to be here when we actually simplify all that out. So negative 45 plus 56. that means the dude is at a height of 11 meters, so the difference is going to be 25 meters difference in height. That's the distance between them. And then position versus time and velocity versus time. Let's be clear. So the guy starts here, moves up, and then falls back down to the ground. And as far as velocity goes, it's going to look something like this. But the whole time the slope should be negative 10 meters per second squared for the slope. So I'm moving forward, moving up, slowing down to rest at the top, then I fall down to the ground. So that is question number 13.